Okay, so the first thing we might do is we might write out our related trigonometric ratios. So really important, tan is actually sine of A over cos of A. So if ever you've sine of A over cos of A, that's the same as tan of A. Okay, this is all on page 13 of your log tables. So we're just writing them out so that we can use them. Okay, cot of A is cos over sine. Okay, sec is 1 over cos, and cosec is 1 over sine. If you think about cot of A, that's actually 1 over tan. So that's 1 divided by sine over cos. And we know when we divide by sine over cos, that's the same as multiplying by cos over sine. So that's where that comes from. Okay, but it's more than enough just to know these. Okay, so there are 4 related trigonometric ratios that we're going to use to help us prove some identities. All right, the first one. Can I get rid of the board? Okay. So the first one, okay. Here in your log tables, you've got cos squared A plus sine squared A is 1. That's given to you. That's something we know. Now they're asking us to prove it, okay? So prove that cos squared theta plus sine squared theta is 1. Now to do this, you're going to draw your unit circle. So you'll remember your unit circle is a circle with radius 1 unit. Now we know to get to this point here, it's over x and up y, but when we're in trigonometry, we know that it's cos theta and sine theta. This is your theta here, okay? So we know this distance here is cos theta and this distance here is sine theta. So to prove this, what you're going to do is you're going to do Pythagoras' theorem. Okay? Or you could do the distance formula. Distance formula, I suppose, is probably going to, make it a little bit, I suppose it's proving it a little bit more. So if we're going to use the distance formula, we know that we're finding the distance from here to here, from this point 0, 0 to this point cos theta sine theta. So our distance formula is, x2 minus x1 to be squared, y2 minus y1 to be squared. Okay? So we know the distance, this is our x2, cos theta, minus, here's our 0, 0. Okay, so cos theta minus 0 to be squared plus sine theta minus 0 to be squared. And we know that distance is 1. Now, cos theta minus 0 is just cos theta to be squared plus sine theta minus 0 is just sine theta to be squared, and that's equal to 1. And if I want to get rid of the square root, I need to square both sides. So you get cos theta to be squared plus sine theta to be squared, which is 1. And I know cos theta to be squared is written cos squared theta plus sine squared theta. So I've proven it now. Okay, so you're just showing them, where did this come from? Well, it came from using your distance formula. Okay, using this point cos theta sine theta and this point 0, 0. Finding the difference between, the distance between those two, which you know is 1. Okay, and here when you square both sides, 1 squared is just 1. Is that okay with that?
Yeah.
So we learn that off by heart. Okay, all of these we learn off by heart, or at least we learn how to get them. Okay, now...
So do you use the distance formula every time?
No, just for this one. So it's going to change every time what we do.
But like for this style of question, every time?
Oh no, this is the question. Prove that that's it. Okay, this won't change.
Oh,
how do they ask this? Like
exactly, yeah, exactly like the question here. Prove that. These are some of the proofs that we normally leave kind of till the end, and it is just straightforward. Prove, please. That's it.
Yeah, thank you.
Okay. Now, yeah,
how did you get rid of the square root?
I squared both sides here. So I squared that.
Oh, okay.
And I squared that.
Okay.
Yeah. Okay. Okay, you good? Okay.
Yeah.
So I'm going to keep going with these. Yeah. All right, I'm going to wipe this so. Show that 1 plus tan squared theta equals sec squared theta. Now, what we're going to use here is our identity that we just proved a second ago. Okay, so what we proved a second ago was cos squared theta plus sine squared theta is 1. Okay, now I wonder if we go, yeah, we'll leave this as 1. Tan squared theta, we know tan is sine over cos, so this would be sine squared theta over cos squared theta. Okay, and sec squared theta is 1 over cos squared theta. Sec is 1 over cos, so sec squared is 1 over cos squared. Okay, so all I'm doing is I'm just replacing with some things that I know, and I'm trying to figure out, will I be able to get the left hand side to equal the right hand side?
Does it not matter if there's like a square in it, like it's still the same thing?
It's still the same thing, because when you square a fraction, so like tan squared is sine over cos to be squared. Okay, that's what tan squared is.
Yeah.
And then when I'm squaring a fraction, I'm actually just squaring the top and squaring the bottom. So that's why it doesn't matter, I can just stick a square in it. Now, with sec, it's 1 over cos. And when I square that, 1 squared is still just 1. Okay, so that's why you can just leave it like that. Okay, so we need to get this to look like either the left to look like the right, okay, or vice versa. So let's try something here. If I get a common denominator on this side, what's my common denominator going to be?
Cos squared theta.
Yeah, cos squared theta. Lovely.
Miss, what does the answer from the last part have to do with this?
So I might not need it yet, but I think I'm going to need it in a second. Okay, so I'm just keeping this here as a little reminder that this is something I know, but I haven't used it yet. So coming back to my common denominator, what did I have to multiply 1 by to make it cos squared theta? Cos squared theta. And if I multiply the bottom by cos squared theta, I have to multiply the top by cos squared theta. Now, multiply cos squared theta by 1 to get cos squared theta. So if I multiply the bottom by 1, I just have to multiply the top by 1. So this is what I'm left with. Okay, I'm just working on the left hand side here. So I've got cos squared theta plus sine squared theta over cos squared theta. What is cos squared theta plus sine squared theta? 1. So what I have now on the left is 1 over cos squared theta, and what I have on the right is 1 over cos squared theta. So I've proven that identity because my left is equal to my right. I've shown that this thing equals this thing. So what you're going to do is you're going to take what they give you and you can replace it with something else you know. So I knew tan squared theta was this, and I knew sec squared theta was this. Then you're going to work on one of the sides to tidy it up. Okay, so in this case I got myself a common denominator. Then I know cos squared theta plus sine squared theta is 1. So I just replaced that with the 1, and now I have the left equals the right. Okay. Okay. Now, can I get rid of this?
Yeah.
Okay, thank you. A little note, so just underneath that, if cos squared theta plus sine squared theta is 1, what you can do is you can get cos squared theta by just doing 1 minus sine squared theta. Okay? And if you want sine squared theta, you bring the cos squared over and it becomes a minus. So they might be important. Okay? If we're dealing with all causes and I've got a sine squared, I might replace it with 1 minus cos squared, because then I'll have all causes. So I'll do a few examples of that now. Okay. So prove that sec of A minus tan A sine A equals cos of A. So what we're going to do is we're going to replace something in here. Okay, so I know sec of A is 1 over cos of A. So let's replace that. 1 over cos of A. Now, what was tan of A? That's sine over cos. Okay, minus sine A over cos A by sine A. So all I've done on the left hand side, instead of sec of A, I've put 1 over cos of A. Instead of tan of A, I've put sine A over cos A. Okay, multiplying tan of A by sine A gives me cos of A. Now, if you want to just tidy up again, you have 1 over cos of A. Sine A by sine A is sine squared A over cos of A equals cos of A. Now, over here, I can get a common denominator. Cos of A and cos of A, they're both over the same denominator, so my common denominator is just cos of A. Okay? If you have 1 over 2 plus 3 over 2, the bottom line is the same, so I can just add the top line. That would be 4 over 2. Same thing here. Okay, so I end up with 1 minus sine squared A. So still working on the left the whole time. Now, what is 1 minus sine squared A?
Cos squared.
Yeah, if you go back up here, we said 1 minus sine squared A is actually cos squared A. So what I end up with is replacing that 1 minus sine squared a, I have cos squared a over cos of a. Now, cos squared a over cos of a, that's cos of a to be squared over cos of a. So that means the square and the cos of a cancel. So I'm left with cos of a equals cos of a. I've proven that identity. So even though it's not written cos of a to be squared, we know cos squared a means cos of a by cos of a. Okay, so it cancels from the top and on the bottom. Is that okay?
Yeah.
Okay.
Yeah. So will that be all these questions, just making both sides equal each other?
Exactly. That's what an identity is. You're making sure that the left is equal to the right. Okay?
Yeah.
Now, will you just go back to number 1 for me and will you put a star on number 1? Okay? So, number 1 is a mandatory proof. That means you have to learn it off. Okay? All the ones I'm doing here, 2, 3, 4 and so on, they're identities, but you're not actually, you don't have to learn them off, but you do have to be able to do them some way. Okay? So, like the question can change for 2 and 3 and 4 and the next however many I'm going to do. Okay, so only the starred ones are the ones you learn off by heart. The rest of them, you can learn them if you want, but it's basically you're just replacing things to get the left equal the right. So I'll do another example. Number 4. Okay.
Is it just one that has a star on it?
At the minute, yeah, just 1, exactly. Okay, so prove that tan of theta by the square root of 1 minus sine squared theta equals sine of theta. Can anyone think about what you might do here?
Replace the 1 minus sine squared theta to cos squared theta.
Excellent, perfect, yeah, okay. So tan of theta by the square root, instead of 1 minus sine squared theta, we know that's cos squared theta. Now, the square root of a square, they cancel.
Miss Butler,
Yeah,
do you not change the tan for this one?
you absolutely can as well, yeah, you will, okay. So, yeah, good job. So we're going to, you can do it whenever, but yeah, change that now to sine theta over cos of theta. The square and the square root here cancel, so I'm left with cos of theta. And what happens then?
Cancel them.
Yeah, cancel the cos of theta on both, okay. So sine of theta equals sine of theta. That okay?
Yeah.
Okay, let's keep going. Number 5. Can I get rid of the board? Okay. Okay, so prove that tan of theta plus sine of theta over sec of theta plus 1 is sine of theta. So let's just replace whatever we can. So, tan is sine over cos. And sec is 1 over cos. Where do you think you're going to go from here? Yeah, lovely. So let's get a common denominator on the top and on the bottom. Okay, now I'm just leaving the right hand side the whole way down. I'm probably going to have to wipe the board a lot. You just keep going underneath. Okay, so my common denominator on the top is going to be cos of theta. Now cos of theta by 1 gave me cos of theta, so that's just sine of theta by 1. What did I do to 1 to make a cos of theta? I had to multiply by cos of theta. If I multiply the bottom, I also have to multiply the top. Okay, and on the bottom line, cos of theta is my common denominator again. Cos of theta by 1 gave me cos of theta, so put a 1 on top. And 1 by cos of theta gives me cos of theta, so cos of theta goes on top. Okay, still just leaving the right hand side there. Now, from there, I have the top line divided by the bottom line. Okay. Okay, so
Flip it and multiply.
yeah, exactly. Perfect. So I'm just moving over here, but you keep going down. Okay, I have this sine theta plus sine theta cos theta over cos theta divided by 1 plus cos theta over cos theta. Okay, so that's what my question is, the top line divided by the bottom line. Now I know when I'm dividing with fractions, I turn it upside down and multiply. Okay, so sine theta plus sine theta cos theta. I'm turning this upside down and I'm multiplying. Now, multiplying means top by top, bottom by bottom, and I can cancel those two. So, a shortcut here, if ever you have the same common denominator on the top and on the bottom, you can cancel them straight away. Okay, so I could cancel that cos theta and that cos theta, and what I'd be left with is sine theta plus sine theta cos theta over 1 plus cos theta. Okay, the cos is cancelled away, so there's my top line, there's my bottom line. Now, do you see anything common on the top?
Sine theta.
Sine of theta. So let's factorise out sine of theta. And what I'm left with is 1 plus cos of theta. Okay, so I have a sine theta there, and then I have a sine by a cos there. So sine theta by 1 and sine by cos. Okay, and now that I've that factorised out, I can just cancel the 1 plus cos theta from the top and the bottom. So sine theta equals sine theta. I've that proven. Any issues there? Anything you want me to go over?
No.
You alright? Okay, and just one more little thing here. Okay, can I wipe this? Just a little subheading. Okay, so some of the identities use the sine rule and the cosine rule. Okay, so you'll remember sine rule is A over sine A, equals b over sine b, or that upside down, okay? So that means if I cross multiplied, okay, I'd be able to get sine A on its own or sine B on its own, okay? Bringing that sine A up and that sine B up, and that B comes down, just cross multiplying, okay? So now I have what sine A is using the sine rule, okay? Now, generally, to use the sine rule and the cosine rule, the question is going to mention triangles, okay? So sides of a triangle, sorry. Let's just have a look at our cosine rule. So cosine rule was a squared equals no. A squared equals b squared plus c squared minus 2 times b times c cos of A. So if I wanted to get cos of A on its own, I'd be bringing these over. A squared minus b squared minus c squared. And I'd be dividing by minus 2bc. And that will give me the cos A. So moving the b over and the c over, and then dividing by the minus 2bc. And then I don't like having a minus on the bottom. So minus comes out of the bottom and up to the top. That changes to a plus, that changes to a plus, and that changes to a minus. Okay, so you're just bringing that minus out and putting it in on top with each one of them. So that might be helpful if you're using cos. This one might be helpful if you're using sine. So just an example of that then. In one sec. What number is this?
It's not really a number, it's just after 5, there's no number on the thing.
We go for 6, so on this one, yeah, lovely. Can I get rid of the board? Okay, so prove that in any triangle C cos B minus B cos C equals this. And just to remind ourselves what we had a minute ago, we had cos of A is that, okay? So that's what we had. That's what cos of A is, so we need cos of B and cos of C, okay? So C times cos of B. So when it's cos of A, I'm taking away the small a. So when it's cos of B, I'm going to be taking away the small b, okay? So cos, if we want, you can just write it over here if you want, okay? It's going to be a squared plus c squared minus b squared over 2ac. And cos of c is going to be a squared plus b squared minus c squared over 2ab. Is that okay? So I'm just using different letters depending on what angle I want. Capital A, you're taking away the small a and you've no a underneath. Capital B, you're taking away small b, you've no b underneath. Same, capital C, taking away small c, no c underneath. So instead of cos of b here, I'm putting in this. A squared instead of cos c, I'm putting in this. Okay, and I'm just leaving it equal to the right hand side there. Everyone okay with that so far? My C on top is going to cancel with my C on bottom. My B on the top is going to cancel with my B on the bottom. So I'm left with a squared plus c squared minus b squared over 2a minus a squared plus b squared minus c squared over 2a. Now, I have a denominator that's the same, so that is my common denominator. So I get a squared plus c squared minus b squared. That minus is outside the whole top line. Minus a squared minus b squared plus c squared. And hopefully things just start to cancel. A's squareds cancel. And then we're left with, so that and that are gone. C squared and c squared is 2c squared minus 2b squared over 2a. And now you can see that 2 is common on the top, so pull the 2 out, or just cancel all your 2's. Gone, gone, gone. So what I'm left with is c squared minus b squared over a is equal to what they wanted. So the whole way down you should be rewriting the right hand side the whole way down. I just don't have room. Is that okay? Sorry, I've kept you a little bit long.